Okay, this is our setup. This is the Arduino board, which is drawing power from the breadboard using this red and black wire, which is connected to the positive and the negative terminal. Then the black one is connected to the negative terminal, and the red one is connected to the positive terminal. This red wire over here and this blue wire over here, they are bridging. They are taking power from these two terminals to the inner side of the breadboard. Here and here. Also, this yellow wire and the green wire are taking power from bridging the power from the inner side of the breadboard to the relay module. To the yellow wire is connected to the UCC port, and the green wire is connected to the GND port on the relay module. Also, this brown wire, which is connecting to the inner side of the breadboard from the two terminals, and the white wire is connected to the inner side, is taking power to the moisture sensor over here, which is taking power to the moisture sensor. Coming back to the relay module, there is a white wire which is connected to the which is connected to the pump over here, and also there is this gray wire which is connected to the negative part of the breadboard over here. And finally, there's a this is the power supply, which has a power. The negative terminal is connected to the negative terminal using this purple wire, and the positive terminal is connected to the relay module using this orange wire on the COM port. Finally, the relay module is connected to the breadboard using this blue wire, which is connected to the port number 13 and connected to the in port on the relay module. And this is the wire connecting to the
This is our code, and in our code we start by initializing the sensor and the pump, and then we go here to the main loop. In the main loop, we have the M state. The M state takes the input, is the part that takes the input and reads it from the digital port. And then we have a delay there, and then we have our if statement. In the if statement, if the M state reads 1, then that means it is high, so the water starts pumping. Else, the M state, when it reads low, it stops pumping.
So our project was on a smart gardening irrigation system. So what this entails is that there will be the automation of the plant watering process. So the moisture sensor detects the level of moisture in the soil and automatically triggers the pump to pump water into the soil if more moisture is required.
So one of the major importances of our project is that okay, we know that during irrigation human beings are prone to forgetting, so they can tend to pump excess water in their plants, which is not very good for irrigation. You know that specific plants require specific amount of moisture in the soil. So our project does so based on the type of plants that are that are in the irrigation, we can see that our project does rather it dispenses and calibrates the exact amount of water that is required for specific plants. So that is the major importance and the biggest advantage with this project of ours. So thank you.
So on future improvements, once the system is connected to a garden, the system can be linked to an IoT website. So here you can set the levels for moisture using the app instead of hard coding into the system. So this can make it easier to use, and it's so user friendly to those who will buy it off the shelf.
The system plugin. You can see it stops running after the moisture sensor senses the moisture around the soil around itself. Okay, now this is the connected system. This is the water pumping mast in water, and this is the moisture sensor. And let's run the system. It will stop after it feels like the moisture content in the soil is enough.